Today we're gonna talk about data indexing on Alephium. So first I'm gonna explain a little bit what's data indexing, why it's needed when working with blockchains. Then we're gonna deep dive into how to implement that directly into Alephium, and with one specific use case in which is like building AMM charts, like AN price action charts, for example. So first off, what's blockchain data indexing? So it's simply the process of extracting and transforming nodes data. And of course making it then available to users or other applications. So some examples on Alephium are the Explorer backend, actually, which is listening to nodes and storing in a data store, maybe a Postgres database, the data for the front-end users to be able to access the blocks and stuff like that faster than by querying a node. And one other example is Mobula's market data engine, which we're going to dive a little bit into. So why is it needed? Two main use cases are data analytics, like the block explorers or market data viewers, or even if you want to build statistics dashboards, you will need different kinds of data stores, and the raw blockchain nodes usually aren't designed for these use cases. You need specific databases for specific use cases. So if you want to do analytics, you'll want some specific data stores like Snowflake or ClickHouse, and if you want to do real-time data, you maybe want an application database like Postgres, and you also want to be able to enrich, to add more context to the data. For example, in a streaming, when streaming market data, you want to be able to add a USD value of assets which isn't available on chain. And the other reason you need data indexing is for the dApp stack. It's part of most dApps. Taking the example of AN pool APIs. So when you are working on a dApp, you want to show data to your users. Some of this data is actually directly available on the node. So if you want to show the ALPH balance of a user, you're gonna just have to run this little query, HTTP query, to any node, and it's going to reply with this payload, which informs the user of what's the balance. For some kind of data, that just works, and for some other more complex data sets, like calculating the API of a pool, where you need to know historical volumes, you need to know the TVL, and of course the current pool state. Of course, you still can do that from a node, but it's often slower, not scalable, expensive. For example, in the context of this API thing, you will need to fetch all the historical events, and if the pool has like millions of trades, that's not something you want to do on a user front end, and then get the pool state and then compute. While if you have an indexer that is already doing this work on the background, you save time. So that's why we need data indexers for analytics tools, and also just to power the apps when the data you want to show isn't available on the node. Now, if we deep dive into how to extract directly from Alephium the block data, how to build an indexer on Alephium. So first, let's take a look at different data types Alephium has. So we have blocks, we have transactions, which are pretty standard, and then we have events. Here, for example, this is an example of an event that the node returns. So we can see here the different fields we have. So we have an address, 4 uints, and then another address. So can anyone guess like what's this event? No. Yes, it's a swap. So right guess, but oftentimes you aren't able to be as smart as you might, and you need more context. So one of the things when working with events is that you need to have more context than simply what the node is giving you. You need to be aware of like what's the contract logic to understand, okay, this is a variable, what does it mean? So Alephium, if we compare to the EVM, there is an improvement in the data decoding. On the EVM chains, you just get a byte payload, and you need the ABI to know, okay, what's the variable types, and then how are they split, and on Alephium it's already decoded, so it's a great thing. But there is one trade-off on Alephium, which is that to make the VM more performant, the VM isn't storing variable names, actually methods, names, and even names, and so that you need to rely solely on the types of the event instead of being able to discriminate events with the method names. So you have more performance, but you have more chances of conflict. For example, we are listening to this event. If there is another dApp that is implementing the same data model, but for a different use case, depending on how you index the data, especially on the AM side, we won't be able to differentiate without taking a further look at the smart contract emitting the event. So that's part of what makes Alephium special. And one other thing specific to Alephium is the working with sharded states. So this is the second part here. So for every shard, you need to have an indexer listening to the head of the shard, and because like every app on every shard will emit its own event and will have its own state. So these are the two things specific to Alephium. And when we take a look at like a more standard, that's like the indexer workflow. It's chain agnostic, like it works the same on any chain. So first, when we launch the indexer, we create the latest block. Then we compare it to the block we have in our state. So if we just get started and we want to sync the whole chain, it's going to be 0, for example. If we aren't synced with the chain, if our state block isn't the latest block, we're going to query our latest block plus 1. We're going to ask for the hash to a node. With the node, we're going to ask for the events with the hash, sorry. And then we're going to just process the events and do whatever we want with that. And hopefully we are faster than the chain at producing blocks. And if so, we're going to end up, in that case, when we are done syncing history, we're going to end up with the latest block. If we are close to the head of the chain, there is a risk of reorganization. So anyone is aware of can you raise hand if you know what a reorg is? Okay, I'll still explain, the great audience. So basically, a chain reorg is when there is not yet a consensus of what's the next block, and so maybe you are talking to a part of the chain that is aware of a last block that's not going to be the final block adopted by the consensus. So your node is telling you, these things happened. You add them to your data store in the indexing case, and then you figure out that the chain changed actually. And the way you figure that out is by comparing the latest block parent hash with the last block you have, which is supposed to be the parent hash. And if it's different, a reorg happened. And if a reorg happened, you need to revert all the operations you did in your indexer. So it can, if you inserted data, it means deleting data. If you updated it, it means backfilling the previous data. And set the state of the blocks back to the reorg origin. So you need to figure out how deep was the reorg, and then just get back to the start of the loop, set the state, and restart from there. So this works with all chains, and of course also with Alephium. So if we take a practical example, so how to build AN price charts. So first we receive the swap events from the indexer. So we are in the handler part, the handler section over there. What happens here is that we identify which pool are we receiving events from. We then update the state of the pool, so the pool reserves basically, the token out and the token in. Then we compute the new pair price based on the state of the pool. And we add USD prices to that, because when you're working with DeFi, you are only working with price ratios. So you're going to be aware of, okay, this token is trading at this amount of this other token, for example, with ALPH and other ALPH, like you have this price ratio, but the end user usually wants USD value. So you need to be aware of what's the USD value of both assets to inject that to the trade data. You create your pair tick, and then from that you can just recompute any kind of view you want. Once you have like this base pair ticks, you can have candle charts, you can have metrics like historical volume, stuff like that. And then, of course, you recompute the USD price of the assets, the weighted average price based on the new metrics, because every time there is a trade, the global USD price of each asset changes. I think that's about it. So the next step for us is to open source our indexing framework, make it a little bit more developer friendly. So if there is any dApp working and struggling with data indexing, we'd love to connect to see how we can help. So this is my Telegram.